Episodic memory stores complete past interactions and retrieves them based on meaning. Each interaction is converted into an embedding, and when a new query arrives, we recall the most semantically similar past conversations to provide better context for the AI. An embedding is simply a vector of numbers that captures the meaning of the text, so conversations about similar topics end up close to each other, even if they don't use the same words. Once every interaction is converted into an embedding, we need a way to compare them. That's where cosine similarity comes in. It measures how similar two embedding vectors are, and the memories with the highest similarity scores are retrieved as the most relevant context for the current query. Now, let's put everything together. Every user query follows the same three-step loop. First, we recall the most relevant past interactions using cosine similarity. Next, the LLM generates a response using that context. And finally, we store this new interaction back into memory for future conversations. Now, let's start coding. First, we install the required libraries, load our OpenAI API key from the .env file, and initialize the OpenAI client. Notice we're using two models, one to generate embeddings and another to generate chat responses. Next, we create a helper function called embedTexts, converts text into embeddings by calling the OpenAI Embeddings API. The remember function is responsible for writing new memories. It generates an embedding for the user's message, creates a memory record containing the user query, AI response, timestamp, and embedding, and then stores it in our memory list. Every conversation is now saved and can be retrieved later when it's relevant. Now that we've stored our memories, we need a way to retrieve them. That's the job of the recall function. It first converts the new user query into an embedding, then compares it with the embedding of every stored memory using cosine similarity. Finally, it sorts all the memories based on their similarity scores and returns the top k most relevant interactions, which we'll use as context for generating the response. Finally, we bring everything together in the ask function. First, it recalls the most relevant memories using our recall function. Those memories are then passed to the LLM as additional context, allowing it to generate a more personalized response. Once the response is generated, we immediately call remember to store this new interaction, completing the episodic memory loop. Let's understand this with a simple example. Initially, the memory store is empty. The user asks, "How do I train my puppy?" Since there's no memory yet, the AI answers using its general knowledge and remember stores this interaction. Later, the user asks, "Any pet care reminders for me?" Now, recall searches the memory store, finds the earlier puppy training conversation as the most relevant memory, and passes it to ask. The AI generates a more contextual response and, remember, stores this new interaction as well. As more conversations happen, the AI's episodic memory continues to grow.